Hey, it's been some time since I uploaded some videos, although I did an exam 3 review yesterday. And this question was asked of me by a student in the library, and I thought, why don't I go ahead and make videos one problem at a time, or maybe a couple of problems at a time, and that's what I'm going to do. It'll be from different topics, and the topic will be given in the title, and I'm going to make at least 5 videos every week, maybe one or two problems at a time. So here's the first one. And this one is from Static Equilibrium, deals with statics. So you have a cable right here holding a weight which is actually a mass of 225 kilograms, and you have a strut here that's pivoted at this point, so it's capable of rotation at that point. It's pivoted there, and the mass of the strut itself is acting down because it's a uniform one. Its mass is acting right through its center. It has a mass of 45 kilograms. So, and you're asked to find the tension in the cable. The T1 is the tension in the cable, as you can see, and this is simply a case of applying the condition that the net torque must be 0. If you look at this diagram carefully, you understand that if you calculate the torque here at the pivot, then this weight is going to create a clockwise torque because it's trying to turn it in this direction, which is clockwise. And again, the weight of the strut is also tending to turn it in the clockwise direction. So you have two clockwise torques about this point, and the only counterclockwise torque is the tension in the cable, which is trying to turn it in the counterclockwise direction. So now remember that torque is just the product of the force and the perpendicular distance. So when you calculate the torque due to the 225 kilograms, well, I forgot to mention that these angles are given. This angle is given as 50 degrees. You have this as 35 degrees. And from the geometry of this diagram, you can make out that this angle is 15 degrees. That is because if this is 50, knowing that the total angle is 180, this must be 130, right? And since it's a triangle, the total angle in the triangle must be 180. So you got 130 here and 35, which is 165. So this angle has to be 15 degrees. So that's 15. And then what I did is I went ahead and I've drawn a perpendicular from here to this point. You know why? Because when you calculate the counterclockwise torque due to T1, it's going to be T1 multiplied by this distance. Because again, torque is the product of the force and the perpendicular distance of the force from the pivot. Now, what is this distance? In this triangle that you see, the right angle triangle, this side is the hypotenuse, this angle is 15 degrees. So this is going to be L sine 15, all right? Because it's the opposite side. It's sine 15 times the length of the strut. So that is going to give you the counterclockwise torque. The counterclockwise torque is going to be T1 times this distance, which is L sine 15. what about the clockwise torque? Isn't it going to be 225 times this is the perpendicular distance, see, plus this one is 45 times this distance. And again, I'm keeping it in kilograms because all you got to do is finally you can just change it into force by multiplying with 9.8. So here we go. The clockwise torque is 225 times this distance, and this distance is going to be from this right angle triangle, because this is 50 degrees. This distance is going to be L cos 50 plus 45 times this distance is going to be L by 2 because it's right at the center. 45 times L by 2 cos 50. And then, as I mentioned before, the counterclockwise torque is T1 times AB, and I've shown you that AB is the length of the strut times sine 15, which comes to be 0.2588 times the length. So when I substitute it there, that's what I get. The lengths get cancelled from both sides, and then it's just algebra there. You substitute the numbers and you get it to be that. Divide both sides, and of course add these two, and then divide by 0.2588 to get you the tension. And that is 173.55 divided by 0.2588, which comes out to be 670.61. But remember, it's in kilogram weight. How do you change it into newtons? Just multiply with 9.8. So if you multiply this number with 9.8, you get the tension in the cable. Thank you, and I hope you enjoyed this video. Please subscribe to my channel because you're going to keep getting problems every single day. Thank you and good luck.